Those two things are the same, it's equal to 1. Okay, that log of 1 is 0 no matter what the base is. Log of 10 is 1. Okay, log of 10 means, in other words, here, log 10 is equal to 1. Because no base means base 10. Then the log laws, log A over B is log A minus log B. If the bases are the same, log AB is log A plus log B. Log x to the n is n log x. Okay. You also then have to know, if you have a log equation, so say you have y is equal to log base A of x. Okay? To solve, what we often have to do is rewrite it in exponential form. What's the equivalent statement of that in exponential form? A is your base, so that stays your base. This joins that. So I get a to the y is equal to x. So often to solve a log equation, you'll change it into exponential form, right? Okay. Likewise, if you're given y is equal to x to the n and you're trying to solve for n, how would I go solve for n? Log base, what was your base stays your base. Okay. So that's the theory, guys, that you need to know for log rules. Okay. All of that stuff you're not given. Okay, you need to know how to do that. You've got a log equation, change it into exponential form. You've got an exponential equation, change it into log form, then don't forget your log rules. Finish? Right, so let's just do A and B and then we call it a day. Right. So, for A, it says the first two terms of an arithmetic, I haven't given you that much space here. Okay. The other thing, guys, is your restrictions. What are you allowed to feed into a log? Only positive numbers. So when you get anything to do with logs, if you're solving for x, the first thing I would do is this. Okay, for log 3x minus 5. Then what goes into the log, which in this case is x minus 5, has to be bigger than 0, right? Yeah. So when you get your answer has to be bigger than 5, otherwise it's not valid. Okay? And likewise for log 3 of x, well in that case, just x must be bigger than 0. So if x has to be bigger than 5 and x has to be bigger than 0, what does x have to be overall? X has to be bigger than 5. The number has to be bigger than 5 and bigger than, it must be bigger than 5. So overall, that is your restriction. Okay? So if you don't get an answer bigger than 5, then that answer is not valid. So here, they tell you the first terms of an arithmetic sequence of that and that. Okay? And they tell you the common difference is 1. So, term 2 minus term in an arithmetic, you don't have to write this down, is your difference, right? Okay, so what's term 2 in this case? Log 3x. And term 1 is?
Log 3x.
And what must that be equal to?
1.
Okay, so that's your basis for your equation, right? But to solve a log equation, you have to get a single log equal to a number. Okay, so how do I get a log? How do I get this to one term? Well, you've got a law that says what? That log A minus log B is equal to what?
Log A over B.
Log A over B, right? So go rewrite that. What's that going to become? Yeah. 3
over
x over
x minus 5.
So it's going to be log 3 x over x minus 5, do you agree?
Yeah.
Must be equal to what? 1, right? Are we happy with that? How do I solve the log equation? You write it in exponential form, right? So go rewrite that in exponential form. That's your base. That stays your base. So go rewrite that equation, that log equation as an exponential equation. So what's it going to be? 3 was your base, it stays your base. This goes to the top, so I get 3 to the 1 is equal to what? X over x minus 5, right? Okay, so now what I'm going to do? Solve for x. How are you going to solve for x? Times both sides by? X minus 5. So I get 3 times x minus 5 is equal to x. So 3x minus 15 is equal to x. So 2x is equal to 15. So x, that will really give you nearly enough space for this question. Is that bigger than 5? Yes, so it meets your restriction, otherwise we would put a line through and say it's not valid. You got that right? Good job. Yeah. Alright, nearly there. Okay, then it says converging geometric series. So a couple of things. If a series converges, what kind of series converges? It means that if you add them up, okay, it heads towards, the numbers you start adding become so small that you head towards a constant, right? Okay, what do you have to remember? Your sum to infinity is equal to a over 1 minus r, but it's only going to converge, it says this on your formula sheet, when your ratio lies between -1 and 1. Only geometric series, okay, with a ratio between -1 and 1, those are the only type of series that converge. The rest either bounce around or they head off to infinity. Your graph, by the way, looks like this, n, s, n. As you go up, you start adding, it heads towards your sum to infinity. Okay. So it says term 2, so it's geometric, right? And they tell you, so we're going to be term 2 is equal to -24. Okay? And then they tell you what? Term 3 plus term 4 is equal to, so just start by writing down what you're given, right? Okay? And it's geometric. Okay. So term n is equal to what in general? In an array geometric? AR to the n minus 1, right? So in any geometric, the second term is going to be equal to AR to the 1, right? But the second term we know is -24, right? So -24 is equal to AR. That's going to be my first equation with A and R in it. So just start by writing down what you're given. Are we good with that? Okay. Then they say to you, term 3 plus term 4 is equal to -18. Well, term 3, guys, term n is AR to the n minus 1, right? So term 3 is going to be what? AR to the 2, right? So AR to the 2, okay? And term 4 is going to be what? AR to the? That's term 3 plus term 4, and that must be equal to? That's that equation over there, right? So I've got two equations with two variables. How am I going to solve those? Simultaneously, right? So you can either go get A on its own, or we can get R on its own. I would get A on its own, okay, because then things are going to cancel. So from 1, what's A equal to? -24 over R is equal to A, right? That's still equation 1. Okay, so what am I going to do now? I'm going to sub 1 into 2. I would not have looked at this question. This is where a lot of you kind of freak out. Because you look at the question and think, how the hell am I going to do that? I don't know how I'm going to do it. But what did I start with? Start with just by writing down what I know. Hey, what did they give me? They gave me that, get an equation. They gave me that, get an equation. So if I sub 1 into 2, I replace every A with -24 over R. Sorry, we didn't know. So -24 over R times R squared plus -24 over R times R cubed is equal to 18, right? So the 1 R will cancel here, so you can be left with -24R minus 24R squared is equal to 18. Are we testing quadratics here? No, we're not. So we're going to say naught is equal to 24R squared plus 24R plus 18. Stick that into your calculator. A mode equation. A is 24, B is 24, C is 18. So what do you get? R is? Hopefully one number lies between -1 and 1. You have an answer for?
I got a half and -2 over 8.
And both of those are valid. Okay, because they lie between -1 and 1. Did you guys get that? Just check it. A is 24, B is 24, C is 18.
So you lost negation.
So if you carry it over 18 should be negative.
18, no, I moved it into the right hand side.
Yeah. Oh, sorry.
What did you get?
This is not a number.
And I did it wrong.
A is 24, B is 24, C is
You're getting
18.
imaginary numbers in it.
Yeah,
Yeah.
Both of them.
Yeah.
Have I made a mistake? The sum of the third term and the fourth term is negative. Ah, here's my
You
mistake.
lost a negative.
I lost my negative there. So that was -18, so that's -18, so that's -18, so that's -18, and then that answer's right, eh?
Yes.
Okay, sorry about that.
Okay. General sound.
Are we good, guys? Okay. Right, well done, everyone. Thanks, guys.